Hi everyone. This video is going to talk about the emission comparison of different modes of transportation. We're going to start with internal combustion engines. An internal combustion engine, 2 strokes of the piston are used to drive 1 full rotation of the crankshaft. So throughout the entire 4-stroke process of intake, compression, combustion, and exhaust strokes, they produce a total of 2 full rotations of the crankshaft. In the first stroke, the air intake valve opens up, pulling in air and fuel mixture into the cylinder. This is called the intake stroke. The piston begins to move upwards, compressing the air and fuel mixture to a highly combustible fluid in the compression stroke. The spark plug then ignites, pushing down the piston in the combustion stroke. And then the exhaust valve opens up, and the combustion products go out of the engine to be processed and released through the tailpipe. Another type of vehicle is an electric vehicle. Unlike combustion engine vehicles, electric cars have an electric motor that generates rotational motion directly, so no piston, cylinder, or crankshaft mechanism are required. In the electric vehicle, the gas engine, the muffler, tailpipe, catalytic converter, and gas tank are all removed. An electric motor replaces the gas engine. A controller is used to power the electric motor, and a large array of rechargeable batteries are used to power the controller.
So what are emissions? This is a term used to describe the gases and particles which are put into the air or emitted by various sources. The EPA is specifically concerned with ones that could be harmful to people. These set of harmful principal air pollutants are called criteria pollutants and range from carbon monoxide to sulfur dioxide. What creates emissions? There are multiple categories: point, mobile, biogenetic, and area. Point sources are factories or power plants, and mobile sources include cars and trucks, as well as lawnmowers and airplanes. These 2 figures show different facts about how transportation affects emissions. As you can see on the right figure, transportation is 29% of greenhouse gas emissions, followed by electricity and industry. On the left, you can see of that transportation, 60% is due to vehicles, followed by trucks, aircraft, rail, and ship and boats. Gasoline emissions specifically emit a variety of gases. The 3 main ones are nitrogen gas, carbon dioxide, and water vapor, which are all considered to be benign, except for carbon dioxide, which can be harmful to our greenhouse gas global warming effect. On the right, more harmful ones are considered carbon monoxide, hydrocarbons, and nitrogen oxides. In order to reduce these emissions, modern car engines try to carefully control the amount of fuel they burn. They try to keep the air-to-fuel ratio close to a stoichiometric point so that no fuel is left unburned. All the fuel will hopefully be burned using the oxygen in the air. However, no car operates perfectly, and this is not always achieved. U.S. carbon dioxide emissions from aviation and motor gas combustion were about 1,142 million metric tons, or about 22% of total U.S. energy-related carbon dioxide emissions. The typical vehicle emits about 4.6 metric tons of CO2 per year. Electrical vehicles, on the other hand, since there's no combustion, there are no emissions. The emissions from electrical vehicles result from the plants where the electricity is produced rather than the vehicle itself. In this figure, you can see that coal is the leader in emissions intensity. The 20% of all emissions come from the transportation account. Between 1990 and 2017, greenhouse gas emissions in this transportation sector increased more than any other sector. Burning fossil fuels like gasoline and diesel release carbon dioxide into the atmosphere, and this is why it is such a concern when we think about emissions.
Here is a breakdown of where the energy comes from to supply this electricity. Based on the national averages all across the United States, it mostly comes from natural gases and coal. Compared to gasoline engines, this emissions released by producing this energy is still less than the emissions produced by gasoline engines today, as shown on the right. Here are the breakdown from where the energy sources come from to provide this electrical energy for 4 different states. Ohio relies mostly on coal, which, as we saw in the previous slide, produces a lot of CO2. Washington uses a lot of hydropower, so as you can see, electric vehicles produce a significantly less amount of CO2 compared to gasoline engines. Florida uses a lot of natural gas, which is an average amount of CO2, but still less than gasoline. And Hawaii uses a lot of oil, which produces a lot of CO2 in the air, but still less than gasoline. So why not use electric over gas-powered vehicles? The biggest issue is convenience. They require charging after driving around for 50 miles, and this charging process takes longer than filling up a tank of gas. To charge, it takes about 4 hours, while filling up your gas tank takes maybe 10 minutes. Electric vehicles also require that the batteries be replaced after around 20,000 miles. There's also the initial cost of the vehicle, which is more expensive for electric vehicles over gas-powered vehicles. But overall, the cost of energy is much cheaper than gas prices. And here are the references to the articles used to find information about this video.